Welcome to the instructions for Module 13. The focus of Module 13 will be analysis of variance. Analysis of variance is almost always abbreviated as ANOVA in statistics. And before I talk to you about ANOVA, I want to remind you of the assignments that you should be completing in your Canvas shell. Remember that you will be completing a video response for ANOVA. You'll be completing discussion board and peer responses for ANOVA. You will also be completing a quiz on ANOVA. Be sure to read carefully over your chapter and review the course resources to have a better understanding of ANOVA. This is probably the first time that you have encountered the idea of ANOVA, but I really want to tell you that it's already a concept that we've been visiting this semester. As a matter of fact, if we're running an independent t-test, that is actually the same as an ANOVA for two groups. Now, the power of ANOVA is that ANOVA allows us to look at more than two groups. So, although independent group t-test is the same as an ANOVA, and will come up with the same statistical results, ANOVA adds on our ability to look at two groups or three or more groups. Now, that might not seem like a very important difference, but here what's going on is that when we run a t-test on independent samples, we're establishing our alpha level at p is less than 0.05. So you might just say, well, if we have more than two groups, why don't we just run a bunch of t-tests comparing those groups? Well, every time we run a t-test, we're increasing our probability of making an error in rejecting the null hypothesis when we shouldn't be doing that. So our p level is going to increase. And in statistics, we want to try to maintain the lowest levels of error in our decisions, and that equates to a lower p-value. We want to maintain a p-value of at least p is equal to 0.05. In some cases, we may get p is equal to 0.01, and there we're even more confident about the decision that we're making about rejecting the null hypothesis. Okay, so we can see the link between ANOVA and t-tests, but let's actually go on to look at something that has three groups. ANOVA allows us to look at mean group differences all at the same time without running individual repeated t-tests. Again, that would increase our alpha level. So we're able to maintain alpha at p is equal to less than 0.05 if we run an ANOVA instead of multiple t-tests. Now, we'll just go over the simple ANOVA. But the reality is we could actually use ANOVA to look at more than one independent variable. We won't do that here because that is more intermediate statistics and you don't need to know that for this course. But I do want you to know that it's possible for us to look at more than one independent variable, and it's possible for us to look at more than two groups, and that's the power of ANOVA. Just as we looked at in the independent samples t-test, the ANOVA allows us to compare group means. Now here's the tricky part. We're going to have a new test statistic. We call it the F statistic. It's going to be based on the F table. And this is really a ratio of the difference that we see between the groups and the difference that we see within the groups. So now we're going to be exploring the idea of mean differences both within and between the groups. When we look at differences within a group, really that's error, or what we call residuals. And we look at differences between the groups, that's what we would consider statistical significance, and really what we're trying to maximize when we use an ANOVA to evaluate three or more groups. I wanted to remind us of the example that we see in the textbook. And I've built this example out in your assignments, so I would like you to look it over again so that you can really understand what it means to create different groups. So the example that we see from your text has to do with dividing up applicants who are all applying for the same job. And the groups are divided based on education. So the first group is the applicants that have a degree that's relevant to the job. Group 2 is the applicants that have a college degree that's not relevant to the job. And group 3 is the group that has no college education. And really what the owner of the company who's hiring the employee wants to know is, will that educational background influence job performance? And the applicants are given a job application test. So now we're going to run an ANOVA to see if there is a significant difference between these groups. Please follow up with your assignments as well as the chapter on this example. Before I go, I want to tell you though that if our F statistics comes out as non-significant, then we basically cannot reject the null hypothesis, meaning there's no significant difference between the groups. In our particular example about education and job application, we find the F statistic is significant. So what that means for us is our hypothesis has to do with the difference that exists amongst the groups, but we do not know where that difference exists. Here is where we come up with the idea of post hoc comparisons. Post hoc comparisons are based on the fact that the ANOVA revealed significant group differences amongst the 3 or more groups, but we don't know where the difference lies. So the post hoc comparisons, and usually it's done with Tukey's, but there are various post hoc comparisons, helps us identify where the difference lies amongst the groups. So there's the power with ANOVA. Not only can we reveal a true difference between 3 or more groups, but once we reveal that, we can go in and actually look at the comparisons and find out where the significant differences lie. Okay, I hope you're not overwhelmed with ANOVA. It's one of my favorite statistical applications, and if you have any questions about it, reach out to me. You can post them on the Q&A, and I will see you back in the next video for this course.